One of the things we need to think about when we are looking at types of reactions and predicting what happens is what is known as an activity series. An activity series is a list of metals arranged according to their ability to undergo reaction. So we list the most reactive metals first, and hydrogen is included in here, even though it's not a metal, just kind of as a reference, because that helps us to predict if the metals will react with acid or not. So here is an activity series for metals. Lithium is the most active, then potassium, barium, strontium, etc., with gold being the least reactive in this list. This list does not include all of the metals. And the way we use this list is if metal A is more active than metal B, then A will displace B from a compound. Now, I shared with you about this is a guy going by himself to a party, and this is a guy and a girl going, and they're swapping partners, right? The girl decides that A is whatever. What is the word? How would you describe an awesome guy? Awesome. So the Lego movie, right? So this one is more awesome, right? Or I used to say this is like it's like the list that the high school girls might have kept, where, you know, lithium is the awesomest guy in school and gold is the dork that nobody wants to have anything to do with, right? And another, you know, I forget where this is from, but who is muy más macho, right? Who's more macho, who's more desirable to the ladies, right? So if we have lithium and barium in this scenario here, and we don't care what Z is, she's just some girl, right? So here, if we have lithium plus barium with Z, whatever that is, we can look at the list and we can say, is lithium more active? Is lithium more macho than barium? Yeah, he is. And so the girl came with barium because he seemed pretty good at the time, but then she sees lithium and she's like, oh, wow, that's better. So she's going to leave with him. And so lithium gets the girl and barium goes home alone, right? So that's the idea of the activity series. It can help us predict which metal will displace another in a reaction. You do not need to memorize the activity series. I'll give it to you, either the entire one, like with the periodic table, or just an abbreviated one in a problem. You do not need to memorize the activity series. You just need to know how to use it. So iron metal will react with aqueous copper 2 sulfate. So here's iron metal and copper 2 sulfate. So iron and copper are the two guys in question. And if we go back and look at the list, here's iron and here's copper. Iron is several levels above copper in the list that the girls are keeping, right? So when we look at this, we can predict that sulfate is going to prefer being with iron because iron is more active. Iron's more macho or more awesome or however you want to think about it. And so this reaction will occur. And we actually see this in the lab. This is a reaction that's often done in a general or intro chemistry lab. If you take an iron nail and put it in a solution of copper sulfate, the nail kind of starts to get furry after a while. And that's because you're getting copper deposited on the nail. And the iron is going away. And if you left it there eventually, it would eat away at the iron, and all the iron would go into the solution, and you'd be left with copper. It would not replace it in a nice orderly fashion where you could change a metal or an iron nail into a copper nail. It would probably be kind of crumbly, but it would go to copper. If we look at the reverse of this reaction, if we have copper metal and iron sulfate, if we don't know about activity series, we might predict that they would swap partners as well. But in the activity series, we observed that iron was above copper. So iron was several steps above copper. More awesome, more macho. So here's copper, little dorky, and here's sulfate. Oh, I forgot to make that a subscript. Here's sulfate with iron, and he's quite the catch. And copper's coming in here and trying to get her away from him. Is she going to leave iron for copper? No way. Iron is better. Iron is more active. And so we look at these and we can say NR, no reaction. Nothing's going to happen. Question?
That series, is that kind of based on like weight almost?
It is not based on weight. It's based on experimental observation. So you do things like this. You put an iron nail in a copper sulfate solution. You put a copper nail in an iron sulfate solution. One of them reacts, one of them doesn't. And so that tells you which metal is more active. And so it's experimental. It's not, you can't just predict it off the periodic table. There are some patterns in the periodic table, but you can't get the list directly from the periodic table. Any other questions? Yes?
Let's say you didn't know what it produced. Let's say you didn't know it was iron sulfate plus copper. We only had the formula iron plus copper.
You just had this part.
Yeah, we just had this part. How do we know the charge of iron in order to combine it?
That's an excellent question. If we were presented with iron reacting with copper sulfate, yes, the activity series tells us a reaction would occur. How do we know what the charge on the iron is? The answer to that is you wouldn't. Because iron is one of those transition elements, and it forms a +2 or a +3 charge. I know that because I've done chemistry for a long time, and I remember that those are the two ions that iron forms. You can't get it off the periodic table. Which one will it form in this particular situation? I can't predict that either. That's something that someone would do the experiment, and they would evaluate this product and figure out what the formula was. So, good question. Any other questions? So, looking at a reaction with metal and an acid. Iron metal will displace hydrogen from sulfuric acid because iron's more active than hydrogen. Let's go back to that list again. Here's iron, and here's hydrogen. So hydrogen's fairly low on the list. Most of these metals are more active than hydrogen. Now, hydrogen is not a metal, but it can form a +1 ion, and it can take the place of a metal in an ionic compound. So when we see an acid, what's the cation in the acid? An acid forms hydrogen ions when it's dissolved in water. So we have hydrogen ions here, we have iron. We see that iron is more active, he's going to displace the sulfate. And so you're going to get hydrogen gas. He goes off by himself. Well, he actually goes off with two of himself. But he's like got multiple personality issues, I guess. And we get iron sulfate. Again, we can't predict the charge on the iron because iron is not a predictable metal. Copper is not going to react with sulfuric acid. I should have copied this over here, but here, see, copper. Copper is below hydrogen. Hydrogen is cooler than copper. And so when we look at this, copper in sulfuric acid, nothing's going to happen. Iron will dissolve in sulfuric acid. Copper will not. If you have a nasty-looking copper penny, you can soak it in acid and get it nice and clean. And the copper will remain. You don't want to be putting iron things in acid because it will eat them up. There are a few metals that are so reactive, they will react with water at room temperature. Most metals don't do this, thankfully. Wouldn't that be awful if aluminum reacted with water and you had a few scratches in the paint on your car and it rained and the aluminum in your car was reacting with the rainwater? That would be really bad. So thankfully, there's only a few metals that do this. And here's the list of active metals and their order. Lithium is the most active. Lithium, potassium, barium, strontium, calcium, sodium. And so there is some pattern in the periodic table there, but it's, they're all alkali and alkaline earth metals, but it's not just going straight down the line. So if we look at sodium, sodium metal reacts with water. You've probably heard, they're not really urban legends because it actually has happened, but you've heard of students, when the professor's out of the room taking a chunk of sodium and throwing it into a sink full of water and exploding half the classroom, right? It reacts with water very violently, generates a lot of heat, generates hydrogen gas, which then combusts and goes kaboom. And so sodium is a very reactive metal. There's also an activity series for nonmetals. We're not going to really go into that, but just be aware that there's also an activity series for nonmetals. So the guys also have a list. The anions have a list as well of who's cooler. So what do we need to be able to do? We need to use the activity series to predict whether a reaction will occur or not. So a gold ring is dropped in sulfuric acid. Anytime you have acid, then what you're comparing it to is hydrogen. So hydrogen and gold. We're going to look on the list and see who's cooler, who's more awesome. Well, hydrogen is above gold. Here, hydrogen is in the compound, gold is by itself. Is the anion, sulfate in this case, is she going to leave hydrogen for gold? No, because hydrogen is above. So hydrogen gets the anion. So we would say for this one, there's no reaction. And that's one of the reasons that gold is good for jewelry, because it doesn't react with acids. A lot of the foods that we eat are acids. And that's one reason that you'll sometimes see people have a gold tooth or a gold filling. It wouldn't be good if you were eating ketchup or spaghetti sauce, which is acidic, or drinking lemonade, and it started reacting with the fillings in your teeth. That would be unpleasant. A zinc granule is dropped into hydrochloric acid. So again, we're comparing hydrogen. I guess I should have put AU here. And here we have zinc, and we're comparing to hydrogen. Who is cooler, zinc or hydrogen? Zinc. Zinc is higher on the list of activity. Zinc is more active. Zinc is going to replace hydrogen in this compound. It's not asking us to write the formula for the product. It's just saying, does a reaction occur or not? So this one is yes, there's a reaction. A cadmium foil is put into a lead-2 nitrate solution. So we're looking at cadmium and lead. Which is more active? Cadmium. Here's cadmium. Cadmium is greater than lead. Is this going to give us a reaction? Yes. A chromium strip is put into water. Well, that activity series is not going to help us with this, is it? Does this activity series predict what metals will react with water? No. It predicts which metals will react and displace other metals. It predicts which will react with acid. What do we need to predict if something's going to react with water? We need that list of active metals. So if we go back here, this list of active metals, is chromium on that list? No. If it's not on this list, it's not going to react with water. So chromium strip put into water, no reaction. Any questions? You don't need to memorize either list of activity series or the active metals list. I'll give those to you if you need them.
So the last one, is chromium not on that list? Automatically knows something.
Right. The list of active metals, those are the only ones that will react with water under normal conditions. Yes? Right. Yeah. So,
Are there any exceptions?
Not in this class. Yeah. I mean, we know that it's not a good idea to leave iron in contact with water, right? But can we really say that iron reacts with water at room temperature? It's a little more complicated than that. It's not going to do what sodium does, where it fizzes and forms hydrogen gas. And so for the purposes of questions like this, if it's not one of the listed active metals, it doesn't react with water. The hard thing about teaching intro chemistry especially, but even general chemistry, is sometimes we have to lie to you because we can't tell you all of it because it would take a couple of years, right? So we just give you the short answer. It's like, you know, the 5-year-old asks you where babies come from, right? You come up with just enough of an answer to satisfy what they need to know. You do not go into the whole reproductive cycle that you would do with a 13-year-old, right? It's just not appropriate. And not that you can't handle it, but it would just take way too long. So, did that answer your question? Any other questions? Oops. So we did that one.